Assalamualaikum, I am Nakirudin. In chemistry, to further understand the concept of molecules and atoms, we must know the concept of isomers. So in isomers, there are two types of isomers. There are structural isomers and geometrical isomers. So today, we'll be talking further about geometrical isomers, specifically stereoisomers. So stereoisomers are compounds with the same molecular formula, but the atoms are arranged in different spatial arrangements. So existence of these stereoisomers is known by a concept known as chirality or handedness. So chirality or handedness are molecules that are non-superimposable with their own mirror images. Conversely, Akira molecules are compounds that can be superimposed on their mirror images. So moving on to beautiful Hani here. She's going to further explain more about chirality.
So I'm going to explain using our molecule that was assigned to us. So we were assigned with 4,5-dihydroxy 2-hexene. 2-hexene means the double bond is attached to the carbon number 2. 4,5-dihydroxy means 2 hydroxyl groups are attached to carbon number 4 and 5. So I'll jump straight to chiral carbons. Chiral carbons are carbons that are bonded to 4 different atoms. With this molecule, we can see that there are 2 chiral carbons here because these 2 chiral carbons are attached to 4 different groups. And to calculate the number of stereoisomers of a compound, we can use the formula 2 to the power of n, where n is the number of stereoisomers. In this case, where n is the number of chiral carbons. In this case, we have 2 chiral carbons, so 2 to the power of 2 equals to 4. Therefore, we have 4 stereoisomers for this molecule. So you can move.
Okay, hi, my name is Azim.
My name is Khalil.
Okay,
My name is Azim.
okay, my name is Khalil. So we are going to talk about facial projection. So come here. Now let's focus here. Okay.
So, first of all, we need to know what is Fischer projection. Fischer projection is the flat representation for the 3D molecule. So this is the first 2 isomers or the first 2 Fischer projection for the 4,5 dihydroxy 2-hexene. So, the vertical line represent the bond that directed away from you, while the horizontal line represented the bond that towards you. The intersection between the vertical and the horizontal line represent the chiral carbon. So, as you know, for this molecule, we have 2 chiral carbon.
So chiral carbon is the carbon that is connected to 4 different functional groups. So as you can see in this one, the first chiral carbon is connected to C3H5 and H and OH and another R group. So it is absolutely a chiral carbon. It's same with this one, the second one. It's also connected to 4 different type of functional group, and we can see that as a chiral carbon. So this one is the isomer of the second isomer. Mirror, as you can see, it is the mirror image of the another one. You see the H and the OH is the opposite, the OH and OH opposite.
Yes.
So what can we say about this thing anymore, Azim?
So, what else we can say about it? Let's move on to the
Okay, let's move on to the 3D model.
3D model.
So this is the 3D model of the two isomer we just showed just now.
Yes. As you can see, for the first molecular structure, the first carbon is bonded to 3 hydrogen and bonded to the carbon that...
Oh no,
Oh,
technical.
sorry. So, chiral carbon is a carbon that bonded to 4 atom or group which are different. So, we can see that this carbon is completely not a chiral carbon because it is bonded to 3 hydrogen atoms, while this carbon number 2 are bonded to the same hydrogen. Yeah, it's not. Okay. So, where is the chiral carbon for this? Where is the chiral carbon for this molecule? It is located at the carbon number 4 and carbon number 5. As you can see, the carbon number 4 is bonded to O, which is oxygen, bonded to H, bonded to CH3, CH3, COO, okay, COH, and this also bonded to carbon CH, CH, and CH3.
Oh. Oh, so as we can see, my God. From this angle, we can see that this one is the mirror of. Oh yes, you can see it's the opposite of this one. So we can see clearly that it is the mirror image of another isomer. So let's move on to the third and the fourth isomer.
Hi, my name is Anis.
My name is Hafiza.
So let's move on to
our
third
third and
fourth
fourth.
isomers. So the fourth isomers is the mirror image to our third isomers, which is for isomers for 4,5 dihydroxy 2-hexene. The intersection between the vertical and horizontal line represents our chiral carbon. It is also known as a chiral carbon because it is attached to 4 different types of atom group. The first one is OH, the second one is C3H5, and the third one is H, and the fourth one is R group. So this is the mirror. This is the mirror image for the third isomers. It is also known as a chiral molecule because it cannot be superimposable. As you can see, there's no line of symmetry in this molecule.
Okay, so we move on to our structure model. So look here. This is our model for the 4,5 dihydroxy 2-hexane. This is the first carbon, the second carbon, the third carbon, and this is the 4 carbon which attached with our hydroxy, and this is the 5 carbon that attached with the hydroxy. There are 2 chiral carbons because at the 4 and the 5 carbon, because the 4 carbon it attached with the 4 different atoms. The first is oxygen, and this we can see the hydrogen and the R group, and the other one is at 5, the oxygen, and the hydrogen, and the R group. So this is, as you can see, this is a mirror image. You can imagine this is a mirror, and then it is non-super impossible because if we stack it, it cannot stack. It is different. We will get the different molecule.
It's okay.
And to show it is a chiral molecule. Even if we rotate at any degrees, it will cannot be stacked.
Wow.
Hi. My name is Orfina. Okay, first and foremost, I will explain to you what is the meaning of enantiomers and distereomers. Enantiomers is mirror image isomers, while for distereomers, they are non-mirror image isomers. Okay, for compounds 1, for compound 1, for compound relationship between these two non-mirror image isomers is mirror image isomers is enantiomers, while the relationship between compound 3 and 4 is enantiomers too. But the relationship between compound 1 and compound 4 is distereomers, while the relationship between compound 1 and compound 3 is enantistereomers. The relationship between compound 2 and compound 4 is distereomers. The relationship between compound 2 and compound 3 are distereomers. Next, I will explain to you what is the plane of symmetry. The plane of symmetry is a plane that divides the compound into two equal parts. Okay. First, I will explain to you the plane of symmetry based on the drawing of vista projection on this paper. First, for compound 1 and compound 2, if we divide or cut this compound 1 at the vertical line, we will never get the same part at the both sides. Meanwhile, if we cut at the horizontal line, we also, okay, you can see if I cut this at the horizontal line, you also will never get the same compound at the both sides. If the object, the first object or compound do not have plane of symmetry, this means that its mirror image also does not have the plane of symmetry. Okay, for compound 3 and 4, if we cut at the horizontal line, okay, you can see this at the center, we cannot get the same compound at the upside and the bottom side, and also with its mirror image. Okay, I will show you for 3D. Okay, this two is chiral carbon. If we cut at its vertical line, we will never get the same compound at the right and left side. For this third compound, if we cut it at vertical line, okay, we will never get the same compound also. Okay. The other properties of chiral molecule is they have same structural formula, same molecular formula, same degree of rotation at plane polarized light. That's all from us.
Okay, I hope you've learned so much about stereoisomers today. That is all from us. So thank you for listening and Assalamualaikum.
Bye.
That's all from us.